Right. So let's get started. Let's get started. So I've got a couple of questions for you today. They're not exactly the same as the ones in the assignment, but they're quite similar, and maybe last week they were a little bit closer. But hopefully today we'll do answer some important questions. Just a quick, how many questions have you managed to do for physics out of 13? How many? Just put a number in the chat. How many questions have you managed to solve and you think they're correct? Okay, 10, 13, 13, impressive. 3, 7, 5, that's fine. So big, quite a range. Don't be shy if you don't be shy to put 0. It's perfectly fine. If or 1 or 2, please put a number. Okay, there's at least 30 of you, and I've got 7 replies. Please, everyone, can you put a number? Yeah, that's fine. That's perfectly fine. Haven't started yet. That's fine. That's fine. Okay. 12, 3, 2. Okay. Good. Okay, yeah. So a nice range. You so previous sessions. Do watch the webinar, because I have actually almost solved problem 13 by accident last week. So if you watch the recording, you will know how to solve question 13. And otherwise, yeah. So you don't have to come to these sessions. You don't have to, as long as you do the work and you submit it on time, you can be accepted. Yeah. So it's up to you. I think that these sessions will help you to do better, but they are not mandatory. They are, you can watch them, you can attend them. The beautiful thing is here you can ask questions directly to me, because I've compiled these question sets for you. Okay, so you should be seeing my screen. If not, do let me know. So the first question: what is the difference between a projection? What is the difference between a projection and oh, just give me a second. Can view. Yeah, you can have access to the whiteboard. There is 2 sets of assignments which you're currently working towards too. Yes, you need to do physics and maths. You cannot just take physics or just maths. You need to take both, and you will be accepted if you complete both to a decent standard. Okay, so anyways, this is the whiteboard I'm using. So you can look at it on the screen, or you can. This is a 90-minute session, so we finish 7:30. So the first question: what is the difference between a projection of a vector and a component of a vector? You've probably heard the component, maybe less so as a projection, but they are very, very similar. So let's say you have a vector. You have a vector A. You have a vector A. And you are given a direction. So let's say you are given a direction like this. Maybe just use a different color. You're given a line. Now, if you drop down perpendicular from the vector, so as if you're shining a torch from the top, you're shining a light and you're looking at the shadow. So the shadow is called a projection. Okay. And let's say that this is the line X. We call this the projection of vector A onto the X-axis. So AX is the projection. And it is a scalar because it is the length of scalar. This is the length of this vector. But if you take the actual vector, the blue vector, X, this is called the component of A in the X direction. Okay. So that is the difference. So when we say projection, we mean a scalar. It's a number. And if you have a in the vector in that direction, it's called a component. And if this angle is alpha, then you can say AX is equal to A multiplied by cosine alpha. Now, when I don't use the arrow, I mean it means the modulus. Okay? So when this line can be rewritten as this. I hope I'm not confusing you too much. A cos alpha. So when I'm not using the arrow on top of a vector, that means I'm talking about the modulus of that vector, or simply the length of that vector. And another interesting thing is that if you take a vector, let's say vector A, and you are given a unit vector in a direction, in a given direction, u is a unit vector, and you draw a line, and this would be the projection of A onto U. This would be the projection of A onto U. Okay? And if this angle is, because this angle is, let's say, alpha, we can say that AU is equal to A cosine, or the length of this vector. Okay, let's put it in terms of vectors. Cosine alpha, and sorry, no, lost the train of thought. Apologies. The projection of this vector onto this direction is, so AU is A cosine alpha. And this vector in the given direction, AU, is a vector, is equal to A cosine alpha multiplied by vector U. scrap that. Apologies. So what I'm trying to tell you is that the length of vector AU is simply the scalar product of A, the dot product of A and U. Yeah? And how to prove that? Well, because we know that the scalar product of A multiplied by U is the modulus of A multiplied by U multiplied by cosine alpha, cosine between them. And we know that U is 1. So that's simply A cos alpha. And indeed, we know that the length of this vector is A cos alpha. We've seen that before. Okay? And that is that. So the scalar product of a vector and a unit vector is the projection of that vector on that unit vector. Right. I might have confused at least some of you. Okay, how much sense does it make on a scale of 1 to 10? Please let me know. On a scale of 1 to 10. Okay. Okay, fair enough. I did confuse a lot of you, so don't worry. I'll try to clarify, and hopefully I won't take 7 hours doing that. You have a given direction. A given direction means, well, a given direction. So usually a given direction is a vector, a unit vector in a given direction. So U vector is given a unit vector in a given direction. Okay. And you have vector, let's say vector A. Well, let's use the same notation. If you find the product of A multiplied by U, this is the dot product, and it's defined in our book. The dot product is the scalar product. It is defined as the modulus of A, modulus of U, times cosine of the angle between them. Cosine of the angle between them is alpha. And we know that modulus, because E is a unit vector, that means that this is 1. So this is 1. So this is modulus of A multiplied by cosine alpha. Now let's return to this picture. If we draw a triangle, we can say that let's call this AU. It's the vector in the direction of U. It's the component of the vector A in the direction of U. Sorry, not the component, the projection. Projection, so not a vector. The projection of A onto this line. Yeah, so if we shine a light from the top, this is the shadow of that line. So AU can be found. Well, we know that cosine alpha is the adjacent divided by hypotenuse A, well, modulus of A. And then we can say that the projection of A onto U is modulus of A multiplied by cos alpha. But that's the same thing as here. This is the same as this. In other words, the projection of A onto a given vector U can be found as the scalar product. Of these two vectors. And that's will come in very handy. Does that make more sense? If it makes more sense, type 1. If not, type 0, please. Okay. All right. That's fine. Okay, thank you. I will just type in, if you're still confused, type in using scalar product to find projection. And hopefully that will okay, sorry, I sent that. If you type that into Google, hopefully you'll get some results. If not, ask me again. Okay, some easy questions. So this was a problem about definitions of how do we define things, how do we call things. And problem 2 says you have a vector. This is a column vector, 6 lambda, and the modulus of this vector is 10. And you need to find lambda. Can anyone guess the answer right away? Good. Eight. Ah, Finn. Interesting. Yes, Finn and John. If you first realize that it could be -8 as well, of course. So what we're dealing with, we know that the modulus of the vector is 10. The modulus, by definition, modulus of a vector is the square root of the components, of the squares, the sum of the squares of the components. And it says that modulus is equal to 10. That makes 6 squared plus lambda squared equals 10 squared. So lambda squared is 64, and lambda is plus or minus 8. Okay, lambda is plus or minus 8. So as I said, not a difficult question. We just need to figure out what it looks like. So a vector A, 6 lambda. So make it 2, 4, 6. 2, 4, 6, 8. So it could be like this. A. So this is vector 6, 8. But it also could be 6 minus 8. So it could be like this, which is 6 minus 8. In both cases, the length of the vector is 10. The length of the vector is 10. So that's that. Okay, for different values of lambda. And okay. Right. Problem 3. You have a vector A and vector B. You need to find lambda if the vectors are parallel. Okay, so -1 and 3 is parallel to lambda 5. Now, we need to recall what it means for two vectors to be parallel. Well, if two vectors are parallel, so for example, vector A and vector B, if they're parallel, that means that if A is parallel to B, don't forget the arrows, then there exists, so in maths we use this symbol for exists a number k, a real number k, such that B is k multiplied by A. Okay, you don't have to use these symbols. Like, then there exists a number k, a real number k, such that B is k alpha. Okay, so in other words, minus 1, 3 is equal to k multiplied by lambda 5. So from here we get minus 1 equals k lambda, 3 is equal to k multiplied by 5. So from here we can figure out that k is 3/5 and lambda is minus 1 divided by k, which is minus 5/3. Minus 5/3. When you say vectors are multiples of each other, how do you mean that they're multiples of each other? Sort of. I wouldn't use the word multiple. Because you're talking about multiplying a vector by a number. I thought you multiply k by vector a. It doesn't matter which one you use. It could be the other way around. A good example would be, let's say you have a vector 3, 0, and you have a vector 4, 0, 4, 0, 3, 0, and a vector 4, 0. I don't think anyone will argue that these two vectors are parallel. Yeah, 3, 0 and 4, 0, two parallel vectors. And 3, 0 can be written as 3/4 multiplied by 4, 0. Okay. Or 4, 0 can be, so or 4, 0 is equal to 4/3 multiplied by 3, 0. So in this case, you have A equals KB. And here you have B equals K star A. The double line symbol means parallel, yes, or collinear. So you have different values of K in this case. So in here, K is 3/4. K is 3/4. So here you just have a different K. I call it K star, which is 4/3. So as long as there is a number, it doesn't matter which way you put the numbers. So from here, you can find that K is 3/5 and lambda is minus 5/3. And that's the answer. if the vectors are parallel. So if the vectors are parallel, its lambda is minus 5/3. Now, if the vectors are perpendicular, this symbol means perpendicular. And when are two vectors perpendicular? Can somebody remind me? Dot product is 0. Well done, of course. Two vectors are perpendicular if A dot B is 0. This is the same as to say that A is perpendicular to B. This is equivalence in maths. Or you can also say it's if and only if. Okay. So that means that minus 1, 3 multiplied by lambda 5 has to be equal to 0. So minus 1, so from here, minus 1 lambda plus 3 times 5. 3 times 5 is 0. So minus lambda plus 15 is 0. Lambda is 15. So in the second case, lambda is 15. Okay. So I hope that makes sense. How well do you understand question 3 on a scale of 0 to 10, please? Okay, good. So there are some questions like this in the assignment. Maybe a little bit harder, but anyways, whenever you need to prove that two vectors are perpendicular, you times them and you make them equal to 0. All right, question 4. Now that's not an easy one. Well, kind of. So what do you need to do here based on the previous question? I've just given you a hint. You need to prove that P is perpendicular to A. Exactly. You need to prove, in other words, prove that P dot A is 0. So what we're going to do is just find P dot A. So P is this bit. So it's B dot A dot C. A dot C minus C A dot B dot A. Now, so the scalar product, for scalar product AB is equal to BA. And that is important because it doesn't work for vector product, for example, it doesn't work. So they are commutative. They AB and BA are the same thing, which is not true for matrices, for example, or vector products. So we can write this as AB multiplied by AC. So I'm multiplying A by this and multiplying A by this minus A times C multiplied by A times B. And as you can see, this and this, this and this. So in fact, these are the same things. And so this is 0. And because the dot product of P and A is 0, then they are perpendicular. So P is perpendicular to A. Okay. You know what? I'm just gonna change that slightly, ever so slightly. I'm gonna put A here because it really doesn't matter which way you do it. Okay, because that's the properties of and I think that makes more sense. So if you multiply this out, you're multiplying this out, what you're doing is multiplying by A times B, A times C. Why do you multiply by vector A? Because they are perpendicular if the dot product is 0. So this means that P dot A is 0. Because these statements are equivalent. And that's why you multiply it by A. We'll multiply it by A, and if the product is 0, then it is, and as you can see, it is. In fact, it is 0 because this minus this is 0, because these are the same things. These are two of the same thing. Okay. 3 vectors make a triangle. Prove the law of cosines. Now this is an exciting one actually. So what we're going to do is we are going to write. So let's see. A times B, A plus B. You can from here you can see that C can be written as minus C. So minus C is the opposite vector. This vector minus C. Minus C is opposite to C. And minus C can be written as A plus B. A plus B. In other words, C can be written as minus A plus B. Okay. Does this make sense? How much sense does it make on a scale of 1 to 10? Okay. So far so good. We've established that we use the triangle rule for vectors. We know that vector C minus C is A plus B. Okay. Now, what we're going to do is we know that C squared is C times C. That's very important. C times C. Let's prove that. Well, vector C times vector C. So that means you have 2 of the same vectors, C and C. C and C is modulus C times modulus C multiplied by cosine of the angle between them. But the angle is 0, cosine 0. Cosine 0 is 1. And so in other words, you have C squared multiplied by 1, which is just C squared. Yeah, when I say C, when I say C, it's the same as modulus of vector C. Okay, so get used to that. I will sometimes use modulus of vector C. Sometimes I will just write C without an arrow. C without an arrow means modulus. Okay, and what I'm going to do is I'm going to do minus, so minus A plus B. These are vectors multiplied by minus A plus B. So the modulus goes away. and I get A times A plus B times A plus A times B and plus B times B. David, oh, okay, you got it. Yeah, because C is the other way around, is the other way. Okay, C is left, and C is not A plus B, but minus C is. Minus C. Okay, so I expand the brackets, so the minus goes away, and I'm left with A times A, so just regular. So the scalar product behaves just like a regular product, B times B. Some people call it FOIL. I really don't think that is necessary. And so A times A, we've discussed that is actually A squared. Okay, BB is B squared plus B squared, and then plus 2AB. Okay. Now, if we go back to the definition of the dot product, we will see that, let's use a different color. AB, the dot product, is A, B, cosine, and in this case, because this is vector A is in this direction, and vector B is in this direction, the angle between them is alpha, cosine alpha. Right, so here we can write that this is A squared plus B squared plus 2AB cosine alpha. Does this look like the cosine rule? So this is C squared, by the way. C squared. It's close, yeah, but it's not exactly. You need minus 2AB. So what's going on here? Well, because you found cosine alpha, not cosine phi. You have the wrong angle. So what do we know about these two angles? Well, we know that alpha plus phi is 180 degrees. And in other words, phi, alpha is 180 minus phi. So we substitute that into here. So we get C squared equals A squared plus B squared plus 2AB cosine 180 minus phi. Cosine 180 minus phi. And if you check it, cosine 180 minus phi is equal to minus cosine phi. Okay, minus cosine fine. And here we go. So that is in fact c squared is a squared plus b squared minus 2ab cosine y. And this is what we proved. Now, if you don't know this formula, or you don't understand this formula, well, test it out. Test it out. Test cosine 100. Find cosine 180 minus 10 and cosine 10. And just compare. And do the same with minus 20 and cosine 20. Okay, you won't see it. And the next maths assignment, will be apologies. Okay, the next maths assignment is going to be on trigonometry. Okay, moving on. Okay, so we've done quite quickly. But I said one by one, can we multiply at a time? So with assignments, no, so we have last year's assignments, which are very similar to this year's assignments. They will have slight changes. There will be slight alterations, but I will release them. So the due date for the first assignment is the 16th of October. So on October the 17th, hopefully, roughly October the 17th, the second assignment will be published. So you submit one assignment and then you start the other one. Okay, so that's how it works. I don't think I can do them too much in advance. It just takes time to prepare them. Okay. Question 6. Now, question 6 is an easy question. Like, there's nothing difficult about it. Why I want to talk about is question 7, because question 7 is a bit harder, and people get confused. So question 6: an airplane is taking off with speed 220 kilometers per hour, which is roughly correct for a jet airliner. At an angle of alpha 20 degrees, find the horizontal and vertical components of the velocity. Right, so, well, this is 220, and the angle is 20 degrees. It's quite straightforward from here. It's something you need to be very comfortable with when you do physics, that the horizontal component, the horizontal component is V multiplied by cosine alpha, and you get some number, which is, don't forget to put your calculator into degrees. So 220 times cosine 20, 207. 200 approximately, of course, 207 kilometers per hour. And the vertical component is V multiplied by sine alpha equals sine 75.2 kilometers per hour. It's very straightforward. Now let's look at the next problem. Now let's look at the next problem. You have a boat which is traveling at which is being pulled. A boat is being pulled towards the shore with speed v, as shown on the diagram. So there's a rope. The rope is being pulled with speed v, and we need to find u, the horizontal speed. So what people do very often is they say, okay, we have speed v, and we break this into a horizontal and vertical component, and break this down into horizontal and vertical components, and that's and do the same thing. So u is v, because this is v, of course, because this is v multiplied by cosine alpha. That's a very common mistake. The problem is that there's no vertical velocity. The boat does not have any vertical velocity. Therefore, this is inherently incorrect. Like, you want to find the horizontal velocity, but you are basing this on the assumption that there is a vertical velocity, which is not. The boat is moving horizontally. So what you need is to find the component of the boat along the rope and the component of the boat perpendicular to the rope, component of the speed of the boat perpendicular to the rope. And in this way, so this is u along the rope, let's say parallel to the rope, and this is u perpendicular to the rope. And you can see that u parallel is u cos alpha. In other words, but this is v. The component of the speed of the boat, the component of the velocity of the boat along the rope is this, which is v, because that's the speed of the rope. In other words, u is v divided by cosine alpha, not multiplied. Okay, do you feel the difference? So in the previous example, you had v, and there was u, which is v cos alpha, because there was a vertical velocity. So that's the previous, this is the problem 6. This is the problem 6. And here, this was u sine alpha. And here, it's different. U is v divided by cosine alpha. So this is a different scenario. So in the previous example, it was v multiplied by cosine alpha, and here it's v divided by cosine alpha. So just give that some thought. Yeah, if you, I'll move this here. Okay, it's just you need to be very accurate when you do components of vectors. Don't get fooled by the seemingly easy problems. Okay. Any questions? Any questions? Why is it different? Why it is different because the plane is moving right and up, whereas the boat is just moving to the right. And that's where the difference is. Okay. Do ask me. I mean, this is not easy stuff. I mean, it seems easy, but it's actually not that easy. Okay. Right. should it be u divided by sine alpha? No, well, no, because u over sine alpha is going to be the no, u over sine alpha won't make any sense in this case. Not u, v over sine, or v over cos. V is the speed of the rope, and u is the speed of the boat. Six and seven basically the same thing, except different components are. Okay, let's do it one by one. Let's do it one by one. Samuel, will we ever have to resolve more complex vectors? Maybe, but not that much harder. Should be u divided by sine alpha. Well, no, because in this case you're resolving u into two components, into a component parallel to the rope. Parallel to the rope is u cosine alpha, and the component perpendicular to the rope, which is u sine alpha. And the component of the speed of the boat parallel to the rope is the speed of the rope. It has to be. So this is equal to v. And from here, you find u, which is v over cosine alpha. Alpha 2. Why is u parallel and u perpendicular on the vectors? Well, that's what I explained. This is u, and this is the u parallel to the rope, u perpendicular to the rope. So the boat is moving parallel to the rope, but also moving perpendicular to the rope. So you can say that the velocity of the boat can be thought as velocity in two different directions. So down and right. Karen, are 6 and 7 basically the same thing except different components are labeled V? Well, no. V is the angular speed in both cases. V well, in first case, V is the total speed of the airplane, and in the second one, V is the speed of the rope. So it's the speed of the boat in the direction of the rope. That makes sense. So the actual speed of the boat is higher. If you think about it, U is going to be, in this case, U is going to has to be greater than V. And that's actually this is an excellent clue for you. This is an excellent clue because from the diagram, it is very obvious that U is going to be greater than V. Whereas here, U has to be less than V. The horizontal component has to be less than the total speed of the airplane. And this is a hint because cosine alpha is always less than or equal to 1. So the only option is to multiply V by cosine alpha. And here, because cosine alpha is less than 1, then you have to divide. If that makes sense. That's another, this is a clue. It's not a way to do it. Right. We have the last question. It's a big one. A ladder. So in 6, the V is the speed of the plane, whereas 7 V is one of the components. Yes, exactly, Karen. Problem 8. A ladder AB is placed against a wall. the end A moves to the right with speed v. Find the speed of the end B when the angle is phi. Okay, so you place a ladder and you kind of want to figure out what happens when the bottom of the ladder moves, the top of the ladder moves. Okay, so you want the speed of this end of the ladder, and how does it compare to the speed of this end of the ladder? And I'll try to give you 3 solutions to this problem. Okay, so the first solution is to say that let's say the x, this is the x-axis and this is the y-axis. So x, and let L be the length of the ladder, and this angle is phi. So x is L multiplied by cosine phi. Y is the coordinate of B, is L multiplied by sine phi. Okay. Oh, I've thought of a fourth way of doing it, but yeah, I don't think that's appropriate. Okay. Now the speed of x. The speed of x. Now, let's say the ladder moves slightly. The ladder moves slightly. Now the angle changes. So this was x. Now it is x plus delta x. This was y. Now it's y plus delta y. Now delta y is negative. Okay, so the length, this component y plus delta y, and this is just y. This is y. This is y plus delta y. Delta y is negative, and this is phi, and this angle is going to be phi plus delta phi. And you can see how quickly it gets complicated. So we know that v is delta x divided by delta t, and v is delta y divided by delta t. Okay, now so x plus delta x, so x plus delta x is equal to L multiplied by cosine phi plus delta phi, and y plus delta y is L multiplied by sine phi plus delta phi. Okay, so, and from here, from here you need the formulas for cosine of the sum, sine of the sum of two angles. There's a lot of trigonometry involved here, and we could get an answer. So we could get an answer, but it looks incredibly complicated. Incredibly complicated. It's just unnecessarily complicated, as a matter of fact. And so let's stick a pin in this for now, because I wouldn't really want to go through solving this using this method. So what you would do next? Well, basically what you need is to find delta y. You need to find delta y and plug it in here, and to find v. Okay, which doesn't seem very nice. So this is method one. Method one uses trigonometric identities for sine of a plus b and cos of a plus b. Okay, so not very pleasant. So we're going to look at method two. Method two. We're going to notice that the total length of the ladder does not change. Well, the length of the ladder does not change. So L, on one hand, it is equal to the square root of x squared plus y squared. That's in the first case. On the other case, it is, well, we can simplify that as x squared plus y squared. But it also means, because this is x plus delta x, and this is y plus delta y, we can say that L squared is equal to x plus delta x squared plus y plus delta y squared. Okay. Now, so we're going to expand this. Going to be x squared plus 2x delta x plus delta x squared. We don't need the first bracket. Plus y squared plus 2y delta y plus delta y squared. Okay. And that has to be equal to x squared plus y squared, because it's still L squared. So that's equal to x squared plus y squared. So x squared cancels out. I won't do it here. So we have 2x delta x plus delta x squared. Okay. Plus 2y delta y plus delta y squared equals 0. And now we actually need to do some physics. We need to understand one little thing, that delta x is a small change in x. Delta x is a small change. And as well as delta y. Delta x and delta y are small changes in the respective coordinates, right? So we are moving them ever so slightly. And we need to realize that this, if delta x is small, delta x squared is even smaller, because you're multiplying a small number by a small number, it gets even smaller. So let's say delta x is 0.01, delta x squared is going to be 0.0001. Not quite. You need to compare them, and you will see that this bit is much smaller than this bit. Okay, so we can say that this and this can be negated. Okay. No, it's so this cannot be negated, because let's say x is, I don't know, what's the length of the ladder? 2 meters. 2 meters times 0.01 and 0.0001. So these two are very small compared to these two. So this is physics, yeah. This is this is what we do in physics. We try to make our life simpler. Strictly speaking, if you find the limit, you'll have the same result. In other words, you have 2x delta x plus 2y delta y is approximately equal to 0. Right. Now we recall from the previous result that x is L cosine phi. So it's going to be 2 L cosine phi delta x plus 2L sine phi delta y is approximately equal to 0. So 2 cancels, L cancels. We divide both sides by t, by delta t, change in time. We get cosine phi delta x delta t plus sine phi delta y divided by delta t, approximately equal to 0. And delta x over delta t is v, so cosine phi v plus sine phi small v is approximately equal to 0. So in other words, small v is v multiplied by cosine phi divided by sine phi with a minus. The minus is not really important. If you don't put the minus, it's not a big deal, because, well, v is negative in the sense that the distance between b and the floor decreases. Okay. Right. So not an easy one, but I think doable. I mean, what I wanted to do this, I really wanted to show you how you think in physics. If you have terms like delta x and delta x squared is going to be much less than delta x. So you can take that into account when you're dealing with small numbers. Small angle formula. We will use small angle formula in physics a lot. So yes. Method. Let's talk about method 3. Method 3 is the easiest one. Method 3. So let's go back to the ladder. Probably should I redraw it? Yeah, definitely redraw it. Okay. Copy, paste. Okay, that makes more sense. Now, what we're going to do is we're going to um, split the velocity into two components, parallel to the ladder and perpendicular to the ladder. Split both velocities into components parallel to the ladder and perpendicular to the ladder. Okay, so how does that work? Well, this is the velocity. It can be split into a component perpendicular to the ladder and parallel to the ladder. And this is phi, so this is phi. So this is V sine phi. And this is V cosine phi. This component can be split into two, perpendicular to the ladder and parallel to the ladder. And because this is phi, this is small v sine phi. And this is small v cosine phi. Now, to the interesting bit. Now, because the distance between A and B is fixed, the components along the ladder, in other words, this component and this component have to match up. Otherwise, the distance between A and B would change. Okay? So the distance between A and B is constant as long as the two velocities parallel to the ladder are the same. Is that making sense? What I'm saying, that the components along the ladder have to be, for A and B, have to be the same. Otherwise, the distance between A and B would be changing. How well do you understand that? That small little fact on a scale of 0 to 10. Okay, yes. So if two people are carrying a ladder, they have to be traveling with the same speed. Okay, that's a given. Okay, therefore, yes. So these have to be the same. So in other words, capital V cosine phi has to be equal to V sine phi. And we get the answer. V is V multiplied by cosine phi divided by sine phi. The same answer. Okay, the same answer as before. So you see, in physics, it very much depends on how you look at things. You could go very difficult, moderately difficult, and very easy. So there's a lot of physics involved in here, slightly less physics involved in the second method, and almost purely maths in the first one. Okay, so maths approach, physics approach, and like physics of the 70th level approach. Yeah, so this is problem solving. So remember this, the problem with the rope in the assignment. Like, how do you do it, or how do you find the amount of rope on the left and on the right? Well, you try to simplify it. So what is it? What is it in this case? Well, you can treat the two pieces of rope as two separate bodies. Body 1 and body 2. Left part of the rope, right part of the rope. What are the forces? Well, there's a force here. There's gravity and there's tension, right? So you have 1, 2, 3 forces on this piece of rope. So this piece of rope can simply be replaced by one piece. The right hand piece, another bam, bam, bam. So the three forces, and that's how you do that problem. So it seems like it's a very difficult problem, but actually, if you just replace if you replace the rope with a simple body, it works. We do have time, and I do want to try another approach using derivatives. So that's going to be a method 4. Method 4. I haven't tried this before. It might not work, but I have a good feeling about this one. So x is L cos phi. Now I'm going to find the derivative of x because I know that the velocity v is the derivative of dx on dt. So that's going to be L. L is a constant. So the derivative of cosine is minus sine phi. But we have to use the chain rule here. Don't worry if you don't know this. You might not have come across this. Use the chain rule here and multiplied by d phi dt. And here on the other side, y is equal to L sine phi. And v is minus dy on dt. Minus because it's decreasing. The size, the vertical height is decreasing. That's why it's minus. So it's going to be minus L cosine phi d phi dt. And from here, d phi dt is equal to v divided by L sine phi with a minus. And here, d phi dt can be expressed as v divided by minus L cosine phi. And combining the two, yes, my feeling was correct. Combining the two, v minus v over L sine phi is equal to minus v over L cos phi. L cancels, the minus cancels, and you get V is equal to capital V cos phi over sine phi, the same answer. So there are 4 different ways to do the same thing. I haven't finished the first one. Do try if you like doing lots of maths, to give it a go. Another method which you would probably understand better once you've done derivatives or sorts. The question, yes. So the bottom of the ladder is moving with speed v, and the top of the ladder is moving with speed v. So you need to find an expression for v in terms of capital V and angle phi. Method 3 is nice. I agree. I think method 3 is personally my favorite because it's the most physics method. Method 4 and method 1 are purely maths. So it's up to you how you like it. It's up to you how you like your physics. Do you like your physics in maths? Doing maths and physics, or the other way around? Okay, so I've run out of questions for you. I hope that was useful for you. Do watch the first webinar because it was much closer to the actual tasks. Any questions you have? Don't be shy switching your microphone on. Yes, it's good to see some faces today. So thank you for that. I always appreciate that. Any questions? Okay. Well, if there are no more questions, so next week I'm going to do maths. So I'm going to do some more quadratic functions, and then it will almost be time to do the to submit it. But yeah, we'll see how it goes. Math session next week, same time. And yeah, so well done, and see you next week. Welcome.
Thank you.
Welcome. See you.
Bye.
Bye.
Thank you.
Thank you, sir.
Welcome. Good to hear you. Right. Okay. Switching off. See you next week.